Good morning. Today we are going to learn about op-amp integrator circuit. Integrator circuit. So what it is going to produce output voltage V naught is a integration of integration of integration of input voltage. Integration of input voltage. My input voltage I am calling it as an VI. VI. My output voltage I am calling it as an V naught. V suffix 0. So my non-inverting terminal is grounded. So what is the inverting terminal input? Node voltage is 0. So I am assuming this node as VA, so that this node voltage as a 0. Now I am going to apply the Kirchhoff current law. So the current which is flowing through this R1 resistor, I am assuming it as an I1, and the current which is flowing through the capacitor, I am assuming it as an IF, feedback capacitor current. So which according to the Kirchhoff current law KCL, we will write the currents entering into the node equals to current leaving from the node. The current which is entering this into this node is I1, and the current which is leaving from this node is IF. So I1 is equals to IF. IF. Now I am going to write the equation for IA1. I1 is equals to V by R. So V is the VI, my input VI minus this node voltage is VA by R value is R1 equals to, I am writing the equation for IF. So IF is equals to actually the current through the capacitor. The current through this capacitor can be written it as a C into d by dt of voltage across the capacitor. So the voltage value is VA minus V naught. So VA minus V naught. VA minus V naught. So according to the virtual ground concept, actually if non-inverting terminal input is 0, this one is connected to ground, that's why it is 0. Automatically VA value is 0. Now I am replacing this VA value with 0. This one is 0 and this is also 0. Now this equation can be rewritten as V1 by R1 equals to C into d by dt of V naught, output voltage V naught. So minus is there, so I am writing the minus front. So now this equation, we are going to write the equation for a output voltage V naught. So we need to prove that output voltage V naught is equals to d by dt of V naught, d by dt of Vi, or we are going to prove that integral of Vn. So we are going to prove that output voltage V naught is equals to integration of input voltage, this one. So that's why I'm going to take the integration at both the sides. Integration both the sides. Now integration is applied at both the sides. So that it will become integration and differentiation is cancelled. Integration and differentiation is cancelled. So this equation can be modified as integral of v1 by r1 is equals to minus v naught, c into minus v naught. So I am taking the c this side, so we'll get just a minute. This equation can be modified as v naught is equals to just a v naught is equals to this equation I'm rewriting here. V naught is equals to minus of c into c by r1 into, I'm taking the r1 outside, integral of v1 into dt. So we know that V1 is our input voltage. I'm writing it as an VI. So this equation is clearly telling that our output voltage is the integration of input. Our output voltage, that is V naught, is an integration of input. input voltage. Okay, this is the equation for op amp integrator.